Mhm.
Wonderful. Moving on to Westlight AI, just make sure you, Mitch, check in the Q&A. You have a couple questions. Thank you
Yes,
so much.
thank you.
All right, thanks for having us today. Before I get started, I just want to say that the presentations I've seen so far look really interesting. It's like I'm back in grad school again. So let's talk about Westlight. At Westlight, what we do is we secure your data and not your infrastructure. So if you think about that for a minute, if you think about recent attacks, things like SolarWinds and other high-profile incidents, the concept that you're going to keep intruders out of your infrastructure really is very dated. It goes back to, frankly, the 1990s. And what we do at Westlight is we presume that your infrastructure has been compromised. And then starting from there, we figure out how to protect your data anyway. What we have is unique AI technology for data access anomaly detection and mitigation so that we can still protect your data even after file exfiltration occurs. For those of you who are familiar with zero trust networking, this is zero trust, but for files. Now, let's talk more about data. As you know, data is gold. And at Westlight, we think you should know more about it. So whether you're posting data onto a social media service that may share your data in unexpected ways, or perhaps you're designing a US military aircraft and you'd prefer it to stay in the US, deep fake videos, tracking on your smartphone, the list goes on and on. And at Westlight, the question we ask is not only what if you had a data map, but also control of that data no matter where it is on the map. So what that means is you understand your data sources, you understand how the data is being changed and processed and mixed with other data sources, and you understand where the data is going to. Now, there are a lot of blockchain startups out there that claim to give you this data map, but nobody's talking about giving you control over the data even after it left your system. And so that's what we do at Westlight. You can remotely take control and take action. So we tie user behavior around data access to the actual granting of the data access itself. This is something that's pretty commonly done in classified military environments, where you have an army of people watching what people do with their data and potentially adding restrictions manually. What we do is we use AI algorithms to do this so it becomes affordable and you can use it in commercial applications or for protecting CUI, for example. Next slide, please. Just quickly about the team. Myself, I have a PhD in electrical engineering from Stanford. My thesis topic is quaternion neural networks, and I'm very much in machine learning. My CTO is the former head of the design engineering team at Nokia. So the first innovative product of any type that they would build was his project. So the first multi-million user cloud install, the first embedded satellite system, and so on. We're being advised by Calvin Cam, who works closely with the General Services Administration. Calvin brought 3D building models to the construction market, which is our first target market on the commercial side. Craig Schultz is a cybersecurity expert from MIT. Karen Pieper runs some of the largest databases in the world at Facebook. Mike Lyons is the co-creator of the Stanford Technology Ventures program. And Mary Korn is also a serial entrepreneur with deep connections in the Valley. Next slide, please. Thanks. So how Westlight works, very briefly. When you request to access data, what we do is we intercept that at a very low level in the operating system at the virtual file system level. And we send that off to a remote platform asking all sorts of questions around metadata. So what program is looking to access the data with what process, who is accessing the data, what did they do recently, and so on. And then we feed that into an AI decision engine, which is basically like a credit card fraud detection algorithm. And from there, you can take a remote action, whether that be deleting the file, granting access, and so on. Next slide, please. We're working with Kessel Run in the US Air Force to protect software source code. So as has been well documented, many of the F-35 hardware designs have left the country unintentionally, and this is to protect the software so that doesn't happen on the software side as well. Next slide, please. And on the commercial side, we're working in the construction industry. Imagine you're building an embassy or a bridge or a tunnel or an oil rig. And you have this project where you have hundreds of contractors, many of them small businesses. Imagine a plumber who works out of the back of a pickup truck. Folks like that don't have the budget to deploy traditional cybersecurity solutions, nor do any of the existing commercial products, which are highly network focused, really do a lot for that sort of scenario. And so in construction, they're also moving to digital workflows right now. And what this means is that they need to figure out how to secure a distributed, cloud-based, borderless environment using new tools because the existing ones don't work. Now in the construction space, it's a little bit different from many other sectors because you have lots of different stakeholders, and even a big construction company like Bechtel doesn't actually have that many employees. So unlike Walmart, Bechtel can't dictate the industry. And so what we're doing is we're working with Calvin Chem, who brought 3D building models into the construction industry, and to align incentives across different stakeholders. And so we're currently doing a pilot with the government of Norway. And next slide, please. So thank you for your time today. I'd be interested in any questions, thoughts, feedback. I will open up the floor.
Hey, Aaron, this is Jimmy with Anzu Partners. Great presentation. And you noted this case of construction having unique requirements. I mean, I imagine a similar case happens in defense deployments. And my question is, how much different supervised training is needed for different customer applications? Or do you have some sort of centralized training capability that you can transfer that knowledge between different types of organizations?
Yeah, so that's a great question. Backing up even one step more, when you look in the security space and anomaly detection in particular, something that's a bit of a challenge is that people's behavior changes over time. So imagine you've got a traveling sales rep who all of a sudden starts talking to a new customer, right? That's not a problem, that's expected behavior. And so if you look at supervised training models that look at historical data, they tend not to work that well. And what we're doing is actually an unsupervised approach where we create a different model for each person, and it updates itself in real time. Now, most of the time when you use your computer, you're doing authorized activity. So we build these one-class models that look for your typical behaviors. And then the minute something looks different, we flag it. So does that answer your question?
Yeah, I think so.
Great.
Hey, Aaron, this is Saul from Talis. So this is something in my domain. I know a lot about data protection, data security. Quick questions. So you talk about protecting the data and sort of, how are you encapsulating that data? Are you using a proprietary format, using open things like TDF, or are you doing something novel that keeps it in place and still usable? Because quite often the infrastructure is what you have to deal with. And I have a follow-on question as well, as how much change is required for an application to adopt this?
Right. So what we do is we intercept the data at the VFS level in the operating system. And so it becomes basically a kernel module or a driver or whatever you want to call it, depending on the platform. And from there, the applications don't actually know that anything has changed. So the whole point is that you don't have to modify an application at all. It's totally transparent. On the data encapsulation, what we're doing is we're actually encrypting the data as it goes to disk. So this is different from full disk encryption because you don't have one key for the whole disk. Each file gets its own key that gets essentially released each time a user touches the file.
Thank you.
So this is Reese from Allstate. From a large enterprise standpoint, whenever we bring a data solution or cyber solution to our security operations team, one of the first things they always ask is this a new capability, an enhancement of an existing capability, or a replacement for some other tools.
Right.
How do you see this solution?
Yeah, so I think if you look in the security community, a lot of people will talk about authentication, authorization, and accounting, AAA. And just about all of your network devices have this built in. And we're viewing this as a AAA system that goes into your files. So it greatly extends the visibility that you get of your existing auditing tools. And especially on the commercial side, it's not only security, but it's auditing. And it's much more granular information than you used to have. So we see this as extending your current capabilities and something you'd layer on top, and also as something that can help with new regulations that are coming out, like the new version of PCI DSS, for example.
Thank you.
And
Okay.
one other question. Sorry, I have one more question follow on. How do you differentiate yourself from your competitors in this space? So me being one of them, or at least I was 20 years ago when we created Bormetric, very similar architecture. So curious how you're differentiating yourself.
Yeah, so existing tools that are commercially widely deployed really focus on network metadata, so packet flows and anything in a packet header. In terms of people doing this at the file level, there are some DLP products, think Azure Information Protection, and those all require additional user interaction, so frequently people just ignore the tools. And so this is a fundamentally different approach for the user than what's currently out there.
Thank you so much, Aaron. Great presentation. I'm sure you and Saul have about 3 and 4 hours of conversations we had offline. Moving on, Robotire.
All right, thank you.